Let's learn about functions. And first of all, we're going to talk about a relation. And a relation is a correspondence between two sets where each element in the first set, called the domain, and that's an important word, the domain, corresponds to at least one element in the second set called the range. Okay, so here is a relation, okay? And the first set are all the first numbers in these ordered pairs, okay? So our domain will be -2 and 5 and 8, and we've already written -2 once, so we don't have to repeat it. So that's our domain, and our range will be all the second numbers in our ordered pair. So the range would be 3 and 1 and -3 and 5. Okay, so basically a relation is just a set of ordered pairs. Now a function is a special case of a relation. And a function is a correspondence between two sets where each element in the first set, called the domain, so that's the same as a relation, corresponds to, and here's the difference, exactly one element in the second set. So in a relation, each number in the domain could correspond to more than one element in the range. And now with a function, it can only correspond to exactly one element in the range. So here's our domain, 3, 2, -5, -1, and here's our range, 6, 1, 9, and 8. Now let's go back up and look at our relation. You'll notice that -2 corresponded to two different numbers in the range. It's still a relation, but because -2 corresponds to 3 and to 5, it's not a function. So that's how you tell if a relation is a function or not. If every number in the domain corresponds to exactly one and only one number in the range. Now we can define functions by equations. So think about the equation y equals x squared minus 3x. No matter what I put in for x, we're going to get out exactly one value for y. Okay? Now, because the value of y depends on what we put in for x, y is the dependent variable, x is the independent variable. And here's an important point. Not every equation is a function. So you have to pay attention to that. How are we going to figure out if they're a function or not? Well, we're going to talk about that in this screencast. So let's look at these two equations. Y equals x squared is this parabola here opening up, and x equals y squared is this parabola here opening to the right. So no matter what I put in for x, I'm going to get out exactly one value for y, right? So that is a function. But here, look, if I put in this value for x, I get out two values for y. Okay, so it's a relation, but not a function. And we can simplify this by using something called the vertical line test. If I draw a vertical line anywhere on the graph, and if I move it left to right, if it hits more than one place on the graph, it's not a function. If it only hits one place on the graph, no matter where I drag it, left or right, then it is a function. That's called the vertical line test. So let's use the vertical line test to determine whether the graphs of functions define functions, whether the graphs of equations define functions of x. So here's my vertical line, and I'll grab it and look at that. That vertical line hits two places, so that's not a function. But look at this one. No matter where I put the vertical line, it only crosses the graph of the equation in one spot. So this is a function. Now let's talk about something called function notation. So instead of y, we're going to have f of x. And f is the name of the function. This is a function called f. We can call it anything we want. X is our input, and remember that's our independent variable. Okay, and f of x, that's not f times x, that's one term. F of x is the output, or the dependent values. Okay, so here we have a graph, or here we have a function f, in terms of x, and it's 2x cubed minus 3x squared plus 6. We're supposed to find f of negative 1. So that means wherever there's an x, we're going to put negative 1 in, okay? So f of negative 1 is 2, and you got to watch your parentheses here carefully, okay? Times negative 1 cubed minus 3 times negative 1 squared plus 6. Okay, negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is positive 1 times negative 3 is negative 3. And finally, plus 6. So I get negative 5 plus 6, which is 1. So we say f of negative 1 is 1. In an ordered pair, that would be negative 1 comma 1. We put x in, we get out positive 1 for y. You can also find function values if you can look at the graph of the function. So, for example, what's f of 0? We're going to go to where x is 0. We're going to read off our y value, and it is 5. F of 1 means go to where x is 1, read off the y value, and in this case, it's 2. F of 2 means go to where x is 2, read off the y value. F of 2 is 1. How about 4 times f of 3? Okay, so f of 3 is 2, because that's what y is when x is 3. So that's going to be 4 times 2, which is 8. Now let's go in the opposite direction. Find x such that f of x equals 10. So in other words, what is the x value when the y value is 10? So I go up here to where y is 10, and I get my x value is 5. Now let's look at an interesting question here. We're going to find h of x plus 1, and then we're going to do h of x plus h of 1, and these are not the same thing. This says everywhere there's an x in our function h, replace it with x plus 1. So here we go. H of x plus 1 is going to be x plus 1 squared plus 2 times x plus 1. Do y'all see what I did? I replaced this x with x plus 1. I replaced this x with x plus 1. Okay? All right, so let's finish this out. So I've got x plus 1 squared is x squared plus 2x plus 1 by using FOIL plus 2x plus 2. And my final answer is x squared plus 4x plus 3. Okay, now what's h of x? Well, h of x is what we're given, right? X squared plus 2x. What is h of 1? H of 1 is 1 squared plus 2 times 1. So we're going to get x squared plus 2x plus 1 plus 2 is 3. These are not the same thing. So you cannot distribute a function label, okay? And finally, let's talk about domains of functions, because not all functions will let us put any number we want in for x, okay? There are certain restrictions that we have to watch out for. If you have a fraction, you can never let the denominator be 0, right? So that means x squared minus 25 cannot equal 0. So x minus 5, x plus 5 cannot be 0. So x cannot be 5 or negative 5. So in function notation, or interval notation rather, that would be negative infinity to negative 5, negative 5 to 5, and I'm using all parentheses because we can't equal 5 or negative 5, and then finally 5 to infinity. That's the domain for this function f. Okay, how about a radical function? Well, if I'm taking an even root, I cannot let the radicand be negative. So 9 minus 2x must be greater than or equal to 0. That means negative 2x is greater than or equal to negative 9. And I'm going to divide by negative, so I'm going to switch the inequality, and x is less than or equal to positive 9/2. In interval notation, that is negative infinity to 9/2 with a square bracket because it can equal 9/2. So that's our domain for h of x. Okay, how about g of x? Well, I can take the cube root of a negative number, of 0, or of a positive number. Doesn't matter. So our domain for g of x is all real numbers. And as a matter of fact, if you have a polynomial function, the domain will always equal all real numbers. Okay? So for polynomials, domain is all reals.